think this is the topic I'm looking for. Using systems of equations, inversion, to solve word problems. See, one of the problems you catch with things like Learning Glass and, well, Matt Anderson and a few of the ASVAB players are a different coin for the metrics, right? When I went about putting a few of those in the crypto, or in the model here, especially these recent ones. That's freelance stuff, my own journaling on what I thought my boot barn should look like along with my mill. But that would be as close to reality because they're actually pretty tight drawings. This is actually a transistor. Again, about using systems to give it value, to figure out your first one to that heart rate monitor of actually going, oh, so this isn't an actually complete thing, and you might have to add certain measurements to give those values to something to actually PRT. Now, here's the kicker on that. See this first step that now became its own problem, right? Getting it to the board on a scale in which I can end the word about what math equation I can use to solve a word problem for Alice and Bob's field trip, for Dave's PRT around the college, $2,000 to go to New York City to see Steph and Jenna because the field trip in town about some kids here, rectangle to polar, running around, 10 pounds knife hand. So let's get to it and see. Let's watch it go, given the advantage we have of living on the shoulders of Rockefeller, right?
Welcome back. We're going to look at how systems of linear equations can make word problems easier. Easier? Yeah, easier, which is awesome, right? Because sometimes word problems aren't that fun.
Probably Einstein and Schrodinger and the rest of them doing the same thing.
For however many variables you have, you need at least that many equations to solve them. So what that means is, if you're only allowed one equation, you have to base all your word problems on one variable.
Let's start with functional analysis.
But if we're allowed
we can move into the Fermilab review under the equations that they're doing for spin match direction.
What that means is that we don't have
without value of equation or field or strength. We haven't got that far. We haven't decided. We're just talking right now. You can do an acid, air, water, acid test, or ball and air, ball and water, ball and acid. Change in field, alpha, 1 over air, delta.
Let's see how that interplays in some of these word problems. So we're going to go through, deal some applications.
Slope.
We'll end with a mixture problem.
Glass,
you see, most
ball bearing,
people, when they're
glass
first starting
beaker.
out, really
First
don't
thing that
like
happens in the
mixture
test.
problems. They're sort of difficult. When we're allowed
missing a
two
spring in
variables,
here too, and if the kids don't notice it in the build.
Easier. And I'll show you how that is in the last example. So let's say we got a boy and a girl. They have a total of 57 friends. Right now, I'm reading the problem. We're trying to get a real good picture of what's going on.
Every
so a total of 57 friends. Total. If I add up the boy and the girl's friends, they're going to equal 57. So I'm understanding that. Okay, the girl has twice as many friends as the boy.
See, we'll have different geometry paradoxes because all those equations are high and low derivative. I talk about it like we are the same charge. However, is he 13, I'm 13, 11, 11, 12, 10. It's not up for
I would like to use some variables that make sense here.
And I would also like to do that when,
B, let's let that be
in
the
time
boy's
topology.
friends.
Doing again Rockefeller's tracks here, doing oil and Cleveland or Chicago steel if I put in numbers.
And let's let G be the girl's
and
friends.
Whatever it may today be out in the timeline adjusted to the MTF's cargo tower, right? You don't know, or cargo ship, right? You don't know time dilated. Come in on backsarge, what happened? Well, we got a new calculation. That's how slow that chalkboard might actually move over the plots, the equations. This is
a problem because we didn't know how to deal with two equations at once.
Having
now that we have systems, we can.
something that says somebody hammered that out.
Systems of linear equations.
Okay,
we can
said
allow
that was a safe place to do equation word problems.
Two equations, but we can solve
okay,
two equations.
nothing blew up the universe yet.
Let's figure out both equations.
here
equations.
is some of
Now,
the set.
each sentence is going to tell you something. It's going to tell you a different equation. It's going to relate the boy and the girl in a different way. For instance,
the
the first
planet
sentence,
on a small
a boy and a
surface,
girl have a total
the
of 57 friends.
program of a
What does
video
that
game.
tell you about the
So
friends, the B
I can
and the
add all the
G?
parts
How
in a
much does
beaker.
that equal? What do you get out of that?
If I programmed it though, would it be real rendering to wave functions? And how many of these individual things might take the place? But you'll notice some things about that.
Does it make sense to you?
Again,
Is that what the first sentence is saying to you? Because that's what it says. If we read
what
it
you'll
carefully.
have to notice there is, again,
Second
these are
one,
nice little
the
fire
girl has
starters.
twice
These are
as
nice
many
little flints and
friends as
steels.
the
These are
boy.
nice little, if
The
the
girl has
flint
twice as many
made
friends as the
spark and
boy.
therefore fire what you
figure that
needed for
out.
light,
The girl
the
has,
spectrum
that's an idea of being
of
equal. We'll
what
read
it
through this again.
is
The girl
can only be
has
broken
twice as many as the
down
boy. So
by a
the
vector,
girl
an x, a y. The
has,
name in
girl's
which
gonna equal
boy or girl
twice
still
as many.
doesn't
What's
matter.
the idea of twice
But
as many?
there's is a
Well, it's not
difference.
adding.
Boy A,
It's that
boy
idea
B
of
still
multiplying, but
differentiate
multiplying by
fine
two.
in this equation,
Twice as many
but arbitrarily
as
B
boy.
or
Let's think
G
of it one
could
more time.
reference
Let's make sure
H
we're
or
reading it,
L,
our equation's correct.
or a length or a height, a geometry, an extrusion.
So B is for boy,
So
G
in
is
the
for
same
girl.
way, you
Boy
never
and girl
left the
have a
farm,
total
but
of
it's
57. They have to add to 57.
staying to
But we
X
know more than
parallel
that.
in
We
a
know the
tight
girl has
diagram.
twice as many as the boy. So if I plug
Will,
into the boy,
when the
2 times the
next
boy would tell me the
diagram
girl.
past
If I
the
had 4 for
subparts,
the
as
boy,
long as that subpart,
there'd
which
be
you'll
8 for the
notice
girl.
in
If I had 20 for
every
the
single
boy, there'd be
diagram,
40 for
short
the girl.
of the
girl
base
should equal
structures,
2
the three
times
ones,
whatever
which
the
you'll
boy has.
notice
Does that make sense?
coming up
If
in
it
loops,
does, awesome. Keep
in
on going. If
polygons,
not,
or
think through this a couple more minutes.
how that program and pin chip logic into Droid. Right now,
and in fact,
once I program that logic,
we have one equation. It's already
it
solved
works
for a
like
variable.
Minesweeper. Check this, right?
And solve it.
This
Go
is
ahead and try the first
programming
step right now
AI
on your own, as I do
Minesweeper,
number
right?
4.
But
So I
when the
know
reality
that's
comes to
solved.
now that I want that same mechanism programmed
plus
with
G
B
equals
and G
57.
instead
Now,
of mines
B
or
plus
flags, we're doing something very parallel here. And that's why usually when you go watch an MIT or a lot of other colleges, you'll still see this base tone. And certainly if you get into the big league science, a hydrogen wave function, which is, again, this math doing exactly this. Time topology differentials, sometimes hydrogen in the core of Jupiter, sunshine, or just out there in space.
I know that
By proportion can be
differentialed.
differentialed.
The point where our G's are going to be the same. Let's let them be the same. B
Catch you
plus
next
G,
one.
no.